Well, good day, everybody, and welcome to the Sensation and Perception edition of 5-Minute Psych. In this 5-minute segment, we'll explore our chemical senses, which includes both taste and smell. We often think of them as the same, partly because they both rely on chemical molecules rather than some form of energy, like light waves or sound waves. But we also confabulate taste and smell because we experience them in a very intertwined way. We use both taste and smell to enjoy a meal. And when we're stuffed up, our meal just doesn't taste the same. But even though taste and smell are intertwined, they're different senses with different neural pathways. We'll start with our gustatory sense by asking why we taste. Then we'll look at how our gustatory sense works before briefly discussing super tasters. Then we'll consider why we smell, and we'll end by exploring how our olfactory sense works. Why do we taste? Wouldn't it be better if we could just swallow down all the stuff that's good for us, the Brussels sprouts and the broccoli, without craving the chips and chocolate? No, certainly not for our ancestors who were trying to figure out what's good to eat and what isn't. What's poisonous? What gives us energy? What's food? What's expired? In nature, many nutritious foods are sweet. Many poisonous foods are bitter, and we're actually born with a preference for sweet over bitter. Infants will smack happily to a sweet flavor, but grimace and refuse to swallow a bitter flavor. All of this says that taste was very important in our human evolution, even if it means that today we crave chips and chocolate. When we taste something, the food interacts with saliva and stimulates the receptor cells on the tongue. It's tempting to think that a taste bud is a receptor, but in fact, each taste bud has many receptors. We have somewhere around 9,000 taste buds, grouped in different regions on the tongue, roof of the mouth, and even some in the back of the throat. This means that people without tongues can still taste things. Each receptor responds to a range of tastes, but responds maximally to one of 5 tastes: sweet, sour, salty, bitter, and umami. The sweet and salty areas are located near the tip of the tongue, while the sour and bitter areas are closer to the back of the throat. So think of these 5 basic tastes as primary colors that can be combined in different amounts to account for all the diverse things that we can taste. After the tongue, the signals from the taste receptors are sent to the thalamus and then onto various areas of the cerebral cortex, including reward areas for foods like chips and chocolate. About 1/4 of the population is classified as a super taster. These people actually have a higher concentration of taste buds on their tongue, which researchers can physically count. Not only that, but they react very strongly to bitter flavors compared to regular tasters. Women are more likely to be classified as a super taster than men, and there may be an adaptive significance to this. Since anything the woman eats while pregnant or nursing can be passed on to her child, there's a survival advantage if she can better detect potential toxins in her food. Now we know why and how we taste, but what about its related sense, smell? Why do we smell? Especially if we have taste, why do we need another similar sense? Well, it's that important. And with smell, we can detect chemicals that are distant, whereas with taste, we have to directly interact with the substance to detect it. Smell is also the only sense that bypasses the thalamus and goes directly to the olfactory bulb in the brain. In other words, it has an independent pathway that can still function if the thalamus is damaged. Yes, it's that important. The olfactory receptors line the upper nasal cavity, and to the best of our current knowledge, odor molecules lock into specific receptors that recognize certain odors. Each molecule fits into a specific receptor site, and we have about 40 million receptors. I know that sounds like a lot, but dogs have about 1 billion. Once the receptor is activated by a molecule, it sends a signal onto the olfactory areas in the brain to tell the brain what the smell was. Well, we just explored our chemical senses by starting with the question of why we taste before examining how our gustatory sense works. Then we briefly discussed super tasters before turning to our sense of smell. Specifically, we asked why we smell, and then we ended by examining how olfaction works. Now, aren't you glad you had 5 minutes?